Good evening. My name is Yi Liu from the Nanyang Technological University of Singapore. I'm really glad to present our work. This is collaborated with Tianjin University, Southern University of Science and Technology, and the University of Albert. According to one web market report in 2019, we know that there are over 10 billion websites in the world. There are more than 1 billion users who access our website every week. The whole web market will increase to more than 100 billion after 5 years. However, as we know, there are a lot of bugs in the websites. Bugs not only introduce very bad user experience, but also cause money loss. So the quality of websites is very important. It motivates us to propose techniques for testing web applications automatically. We are facing two challenges. First, the complicated user interaction for web. Second, how to input specific values for testing. Let's consider the example. The nodes are standing for web pages. We want to visit the node with the number 7. With the guidance of navigation model, we could generate an invalidated path from 0 to 1, and then we cannot reach 7. Then we consider another path from 0 to 4 and from 4 to 5, which activates the link between 1 to 7. The previous navigation model does not capture the link between 1 and 7. Next time, we could try another valid path from 0 to 1 and from 1 to 7 to reach the new page. Another challenge in web testing is that we input specific values to explore more web pages. Let's consider this example. To register an owner, we should jump to the registration page and submit the form. It's straightforward for human beings, but for algorithm search space is huge. A typical I/O usually includes the agent and the environment. At each iteration, the agent will select one action to the environment, and the environment will return the state and the reward for this action. Specific to the web testing, the agent is a RL algorithm, which learns a policy to explore more diversified behaviors, as many as possible. The environment is the web application. The web testing process is a continuous interaction between the RL algorithm and the web application. The action can be click and input. The state shows the current state of web. For example, the URL, the current HTML code, the actions could be taken, and so on. The reward function shows the score of the current action regarding the final goal. Specifically, our goal is to find diversified states of the web application, as many as possible. To achieve this goal, WebExplor adopts a curiosity-based policy learning and DFA-guided exploration, where RL is used to learn a policy to explore diversified states of the web applications, and we adopt DFA to improve the testing efficiency. This figure shows our overall workflow. The input is the web under test. We extract the current HTML page from the web application and feed it into the processing component. This component maps an HTML page to an abstract state. After extracting the current state and the valid actions on the web application, we will update the DFA with new states and actions. Here, WebExplor randomly decides whether it needs high-level DFA guidance. If yes, actions for the path will be maximum curiosity value will be selected and dispatched. Otherwise, WebExplor moves into curiosity-based policy learning. This component provides low-level guidance for the exploration of RL, such that the learned policy could explore more behaviors of the web applications. Specifically, the goal is to explore diversified behaviors as many as possible. So we define the curiosity by a tuple, current state S, previous state S prime, dispatched action A, and N is the transition number from S prime to S under A. The Q-value is calculated by the curiosity from S prime to A plus maximum Q-value in current state. The action selection policy is still defined by a softmax, where function G is a node sampled from Gumbel distribution. A is the valid action seed at current state. As for the DFA-guided exploration, we select the shortest path with maximum curiosity. To demonstrate the effectiveness and the efficiency of WebExplor, we want to answer 4 research questions. First, we study the exploration capability in terms of code coverage. Second, we want to find the effectiveness in detecting failures of web applications. Then we want to know how effective the DFA is. Finally, we use WebExplor to test real-world web applications. We use 2 benchmarks for evaluation. The research benchmark is proposed by FSE 2019, consisting of 6 web applications. Besides, we select the top 15 websites as our testing subjects as well. We use 5 baselines for evaluation. Except the random strategy, we use the subweb, a model-based evaluation algorithm. CoreJax, a model-free heuristic algorithm. WebExplor without DFA at WebExplor. We can find that WebExplor achieves better code coverage and robustness in most cases with no navigation models or domain knowledge. Besides, WebExplor achieves the best performance in failure detection. As for the DFA guidance, DFA provides high-level guidance for effective exploration and high efficiency. In real-world web applications, WebExplor still could find a lot of failures. Here is the summary. An interesting finding is that most of the failures are happening in the original web applications, and about 20% of failures are caused by the third-party libraries. Here is a concrete security defect. When WebExplor opens the online editor and clicks on an invisible button, the server fails to load an unavailable module. This defect has caused sensitive information leaking. Besides, we have found more than 300 exceptions and errors in the top 15 web applications. In summary, we propose WebExplor, a new RL-based approach for automatic web testing. WebExplor adopts the curiosity-driven RL to achieve efficient and adaptive exploration. DFA is proposed to provide high-level guidance so as to further boost the testing efficiency. Thanks for your listening. I'm really glad to answer your questions.
Thank you. Hello, everyone. My name is Carolyn Seaman, and I am the session chair for this session on defect prediction and automation. And I have Yilu with me, who was the presenter of the talk that you just heard, and he is ready to take your questions. So let's get started. Our first question comes from Andreas, and he says, "Nice work, congratulations. On the WebExplor project page, you state that the code will be published soon. That was 9 months ago. What keeps you from publishing the code?"
Yeah, actually, we are going to publish the code because we want to fit for more to handle some corner cases. around like how to close browsers and some exceptions. So yeah, after we finish that, we will release our code on the website. Yeah.
Okay, so it's waiting for a few more, a little bit more functionality to be implemented. Okay.
Yeah.
And then we have another question from Mauricio. Thanks for the presentation. He says, if I understood correctly, the DFA is inferred from the web application. Is that so? So we'll stop there. Is that right? Is the DFA inferred from the web application?
Yeah. Yes, it's inferred from the web application. Actually, it's a combination of the state of pages and the actions taken on that page. Yeah.
Okay. So if that's right, do you think the algorithm would benefit from developers providing the DFA? So he's referring to a paper by Matteo Biagiola and Paolo Tonella, where they leverage the page objects that developers often write when writing automated test cases for web apps. The page objects and their relations could be seen as the state machine. Do you think that would be a useful addition?
Yes. Yeah, in related work, we have referred this paper. Yeah, because we have found some limitations under some context. For example, if the network latency is very large, it may broken the page objects. And with the evolution of web application, it could be some mismatch from the page object and the real world applications. So yeah, so we think build a DFA dynamically is a good approach.
Okay, great. So Michael has a question. He says, nice work. Can you elaborate a bit more on how you abstract the state of a page, and in particular, how you ensure to not consider similar states as new?
Yeah, actually, it's a very good question because we have worked on that for about 2 or 3 months to find a better way to abstract the state of a page. To be honestly, we cannot avoid the similar states as a new because yeah, if we just infer the page structure and the URL and some valid actions, it cannot guarantee the state is unique. So in our DFA, there are some duplicate. However, in our algorithm, we will take some heuristic functions to avoid this kind of situation. Yeah. Specifically, we use the URL and the HTML code of the page and the valid action as our state. Yeah. Thank you.
All right, the next question comes from Chanduk. Could you please explain how you formulated the RL's properties, like policies, reward, etc.?
Yeah, actually, we have write safe formulations on the paper. Yeah, so we take the agent as the browser. We take the environment as a web application. We take every actions on the web as our action, and we treat the reward as a curiosity. So we can calculate the curiosity to calculate the Q value, and then we can try to optimize the strategy and actions to taken to explore diversified behaviors. Yeah.
Great. And Na has a question. What is your next step in terms of this research direction?
Actually, we are going to adopt some domain-specific testing. For example, we can testing some single-page application, and we can extract some business logic from the testing process and formulate some unit test. Yeah.
Okay. I had a question. There's no more. Yeah, good. I have a question.
Okay.
Is there either a type of web application or a type of defect that your approach doesn't cover or doesn't work well on? Or is there some area where your approach has a weakness or limitation?
Yes, actually, we should handle some corner cases. That's what I did now to overcome these limitations. For example, if our page needs a lot of domain-specific input, such as the username and the password, it's infeasible to cover all the business logic and pages around the web application. Yeah. So.
I also wanted to ask I forget whether it was on your slide or in your paper, you mentioned hierarchical RL as one of the next steps. And I wonder if you could explain what that means, how that would work, hierarchical RL.
Yeah, actually, we treat the whole testing process as a universal algorithm. But for specific pages, we could apply different policies or strategies to explore the whole web application efficiently rather than a uniform algorithm. Yeah, so that's we should take into account this aspect. Yeah.
Okay, great. Okay, we just have a couple more minutes. Are there any last questions from the chat? I'll give you just a few more seconds, and then if not, then we'll end this Q&A session and everybody will have just a minute to breathe before the next presentation. Okay?
Yeah. Okay.
All right, I think we'll close it there then. Thank you very much, Yilu. And
Thank you.
You can just hit the leave room button and that'll leave it blank, okay? Thank
Yeah.
you. Thank you, everyone.
Thank you.